All right, so now we're going to talk about the vector product. So for the vector product, we're multiplying two vectors, so it's going to be a times b, and it's also known as the cross product, so people may refer to it as a cross b. Now we can define a resultant vector, c, which is equal to a cross b. Note that c is also a vector, and c is perpendicular to both a and b. To find the amplitude of c, we have this equation here, c equals ab sine phi. Note that phi is the angle between a and b, and c is simply the amplitude of the resultant vector. So it does not include the direction of c. It's also important to note that the angle phi is measured from a towards b. So if we look at this example here of a and b, phi goes from a to b. And we should also note that phi must be between 0 and 180 degrees. It can't be any greater. Now to find the c vector, we already have one part, which is we know the c amplitude with the equation, c equals ab sine phi. Now we have to introduce a way to find the direction, which is kind of a strange concept called the right-hand rule. I'll show you how it works. This can be best shown through an example. So we got the xyz coordinate system here with the ab vectors. And the first step is to take your right hand and using your four fingers, excluding your thumb, point them in the direction of A, and then from there, as you can see, I draw a picture of how your fingers should be pointing up. And then the next step, step 2, from there, curl your fingers in the direction of the B vector. And I show below a picture of how your fingers should look as it curls towards the B vector. And you can see that the thumb actually will point in the direction of the C vector. And so for this example, if we draw the C vector in the direction of the thumb, we can see that it points actually in the C direction. So we can conclude that C actually points in the Z direction for this example. And then just to summarize what we went over, so we know that C is equal to A cross B, and then C amplitude is equal to AB sine phi, and then we use the right-hand rule to find the direction of C.